All right, class.
Yes.
All right, thank you all for showing up here because there's a whole bunch of people that are not going to show up to school today because they think it's a half day and they think 40 minutes is not enough of a class. But it's still important to be a class day. Now, right here, we're doing higher order derivatives. So that's going to be the derivatives to the second, third, or maybe even the fourth. Now, when we're taking the derivative, my first one is normally referred to as position. So when we're doing this, we think of it in terms of physics. So my first is going to be position. My second is going to be velocity. My third is going to be acceleration. My fourth is going to be jerk. So it's called jerk. It's an instantaneous, pull of the force as you accelerate. So find second, third, and fourth derivatives. So now, first derivative, I'm going to go y prime. So y prime, so if we do the math, this is going to turn into, what are we going to get here? 6x squared. ¿Está muy fácil?
Wait, so for the y prime, would that be the
first derivative?
So that would be the distance or the
velocity.
velocity.
So but if it was in a physics function, it would refer to the velocity. But velocity is also to get, because velocity could be a positive or negative, but it gives you direction. So if you're asking for the speed, not velocity, they're different. Absolute value. So does that make sense?
Yeah.
Okay.
So y prime is the velocity.
Yeah. So and then y double prime, my second derivative, do the derivative of the derivative is going to give me 12x, and y triple prime is going to be Are we good? Okay. All right, so I know no one in here is going to be a third derivative today. Everyone's paying attention?
Yep.
Yeah. See what I did there? What did I say a third derivative is? Jerk. Don't be a jerk. All right, find the second and third derivatives of this. Now, what type of problem do I have here? Huh? No.
Did you distribute so you
No. I could, but that's not what I'm looking for. What type of problem do I have here? What's happening here? Very good. Product.
Do you have another 2.4? Do you have another? Yeah.
They're in the little file box right there. So it's towards the back. So yeah, it is a product. Thank you. So product or quotient. Quotient would imply that it is being divided, where a product means that there is multiplication. I have two items being multiplied together. So let's identify each thing like we did for this is F, this is G. Okay, every time you're doing a product or quotient, you need to start by doing that. Identify what each item is, because that's where I plug in my formula. So F prime, what is the derivative of that one? 2x? Yeah. And G prime is e to the x. There you go. And let's go ahead. My formula is F prime G plus G prime F. So F prime is 2x times e to the x plus G prime, which is e to the x times F, which is 1 plus x squared. Nope, that's quotient. That's quotient. Quotient means division, so. All right, and so right here, I could identify this and say that would be my y prime. That is a correct answer on a free response. But normally, you need to actually work your free response into something else or make it match, especially on a multiple choice type question. So, do they both have a common factor? They have e to the x, e to the x, right? So I'm going to take out an e to the x, and I'm left with 2x plus 1 plus x squared. And I could go back through and rewrite it. But I will rewrite it because we have to take the second derivative of this. So since I'm taking the second derivative of this, I want it to have in a nice order to make my life a little bit easier. So I'm going to go and I'm going to do another page so you guys can see. So my y prime was e to the x times x squared plus 2x plus 1. Did I write that correctly? Okay. So y double prime is product rule. So again, identify what it is that we're doing. So I'm going to change from my second derivative. So this is f and this is g. So f prime is going to be e to the x. G prime is going to give me 2x plus 2.
So we just do this over and over again?
Yeah.
Just
yeah.
succession for all the derivatives?
Yep. And so make sure you do the factoring out if you can, and it's going to make your life a whole lot easier. Simplify the problem as much as you can, because you want to make your life easier, especially when you're doing your math. So right here, f prime g. So f prime, so it's e to the x times x. What was that?
No, like disable that or something.
I do.
Was that someone's Surrey or something?
Probably is.
The government is listening to you, bro.
I must be special.
They're gonna experiment with you. You're gonna go missing. You're gonna be at the CIA.
Will
He's going to find out what close encounters of the third kind really mean.
Do you want to meet JFK?
Mm-hmm.
We will.
I'm gonna find out what the end of Pi looks like.
You're gonna end up on that episode of South Park. Season 1.
You're gonna find out what temperature steel melts off.
Yeah. Wow, you actually know that? Holy cow.
Well, I
From
deep
you.
into that.
Okay, that movie? You've seen the movie, right?
No.
Okay,
Just the conspiracy theory.
Okay. Anyway, so this is again, that is my y double prime. And then let's go through and let's factor it out to make my life easier. Is e to the x quantity x squared plus 2x plus 1 plus 2x plus 2. I'm going to go y double prime is e to the x squared plus 4x plus 3. Joseph, I know you're paying attention right now, right? Uh-huh. Did you write down all that down? No. Or you just zoned out because you're talking to someone about something? Yeah, I know.
My face got shoved into my straw.
Huh?
I was drinking water and I got shoved into my straw.
Oh, okay.
Yeah.
All right. Yeah. Okay.
I'm not gonna let this slide.
Yeah, so we blame Blade on this?
Blade.
Blade?
Yeah, we always blame Blade.
Yep. Alright, so this is my second derivative. I need to find the third derivative. So that means I have to do this again, right?
X squared 4x plus 3.
change my color here. All right, so again, f prime is going to be e to the x. G prime is going to be 2x plus 4. F prime g, so it's y triple prime is going to be e to the x times x squared plus 4x plus 3 plus e to the x and times 2x plus 4 y triple prime e to the x squared plus 4x plus 3 plus 2x plus 4, and then y e to the x, quantity x squared plus 6x plus 7. Now, you notice I clean up my problem every time so I can go back through and do this. Now, if I would have left it in distributive form, if I would have left it right here, what's happening right here? There's a product happening right there, and there is a product happening right there. So I don't want to go through and do all that. I don't want to have to do my product rule twice. I don't want to distribute this, because if I distribute this right here, that's going to give me a e to the x squared plus e to the x 4 e to the x plus e3 e to the x. So if I were to distribute that right there, I have a product rule there, a product rule there. I would have twice as many product rules. So by organizing, factoring out, and cleaning up my problem, I'm saving myself a whole lot of work. And I am all about not doing too much work.
Can you go on to the second page real quick?
Yeah.
I didn't catch the last bit.
Oh yeah, because someone was being bothered by Blade.
Just like think about.
Okay.
Why does it sound like there's a mouse in your projector?
Someone said it probably got wet.
Oh.
My projector, my little cable thing got screwed up, so now I have to plug it directly into the HDMI. So there is a ground feedback. I know, it's annoying. I can't get rid of it.
It adds rustic charm to your YouTube video.
Oh, thank you, Rusty Charm. So it's kind of like playing an LP, and you guys, there's a little bit of that crackling noise in the background.
Yeah.
Yeah, that's the way it's supposed to be. All right. So, acceleration. How many more slides we got?
One, just two.
Just 2? All right. So, we'll save this for when we get back. So that means we have what? We have 20 minutes of class left?
I think class ends at 8:50.
And we should plan this for a minute, but not be like
Yeah.
at 9 exact.
Yeah.
Oh, it goes till 9. Okay, so yeah, I got enough time. I got enough time to finish. I'll put it up. All right, so acceleration. For an object in rectilinear motion, distance s from the origin at time t is given by a function s equals s sub t. For the first derivative, ds dt, that means that I'm doing a change of the d is delta. That's a change. So change in distance over the change in time is velocity. So it is miles per hour, all that other stuff. So And velocity, v, is equal to v of t of object of the time. Acceleration, a of t of an object at time is defined as the rate of the change of velocity with respect to time. So it's the slope of the slope. So when we talk about a slope, it is either increasing or decreasing, right? So that would be my first derivative. And my second derivative would be, at what rate is it increasing? Is it increasing at an increasing rate? Or is it increasing at a decreasing rate? That second part would be the acceleration of that. So it's increasing speed, but the speed is not accelerating at an increasing speed. It would be like going down. So it's slowing down.
So it's like the speed is increasing at a decreasing rate?
Yes. So that would mean it's still going up positive. It's still going increasing,
Going up less.
but not at the same. Yeah. Go ahead. Restroom? Okay. I'm not doing my thing. Alright, analyzing. A ball is propelled vertically upward to the ground with initial velocity of 29.4 meters per second. That is my initial velocity. Okay, the height, s meters of the ball above the ground is approximately s equals s of t equals negative 4.9 t squared plus 29.4 t, where t is the number of seconds elapsed from the ball is released. What is the velocity at the ball time t? So, to get the velocity of the ball at time t, I need to take the derivative of the position. So that is s of t plus 29.4t. Alright, so that is my position. Now I'm going to find the velocity. So instead of saying s prime, you could write it as velocity. So v of t instead, which is the same as saying s prime of s prime of t. It's the same thing. And this is going to give me a negative 9.8 t plus 29.4. And what is it at 1 second? Say what again?
Can you draw the graph of this? Like what the ball would actually like?
I will. Towards the end, I believe it actually says. And it's asking for t of 1, right? T equals 1. So it's going to be v of 1 is going to be negative 9.8 plus 29.4. So v of 1 is going to give me, what is it, like 19 something? 19.6? 19.4? 19.6? 18.6?
9 minus 29 minus 9.
Yeah, but then look, because you have this up over this. So it would go down.
You know you guys have calculators, right?
29 minus 9 is 20, and then minus 0.8, that would be
19.6. Wow. Yeah, 19.6. Now, what is my units on that? Whenever we're actually doing these problems, we need to label the, huh? Meters per second. So, meters per second. So next one. When the ball reached its maximum height. So if we're throwing it up, think about it. If we're throwing it up, maximum height, what do you think is going to happen right there? Perfect. Exactly. When you throw it up, the maximum height, it's going to start coming down. So the slope at that point is going to be 0. So I need to take my derivative and set it equal to 0. So I'm going to take this, and I'm going to change colors here. So 0 equals negative 9.8 t. So subtract 29.4 from both sides.
Oh, you forgot to put the T on the whatever. Oh wait, never mind, sorry.
Yeah, I'm using this one here.
Yeah.
Or are you talking about this? I plugged in 1, so that's what.
Sorry.
Hey, you're looking out for me. So all people on YouTube right now, and I have some students at Metro Tech that like watching my channel. So they're talking crap about me right now. So, all right, and then divide both sides by negative 9.8. All right, handy dandy calculator for me, please. 3 equals 3. What is the maximum height of the ball? Now, so I want you to really think about that. What is the maximum height of the ball? So what is that really asking for? The y value, and that would be my what? Distance or position, right? My position. So I plug that into which problem?
The original function?
Yes, my position function, my s of t.
Equals 3, right?
Yes. So I'm going to change up colors here. Let's go back to red or whatever I got here. So it's going to be this one here. So it's going to be s of 3 negative 4.93 squared plus 29.4 times 3. You know, I gave you guys a calculator so you don't have to pull out your phone and do whatever. Huh? 44.1. So S of 3 is 44.1 what?
Just 44.1.
I know, what though?
Oh, it's meters.
Perfect. Because it's talking about position, there is no rate on the position. So therefore it's just meters.
That's for question 3, right?
Yeah, 3. 4. What is the acceleration of the ball at any time? So to get the acceleration, I do the, yes, or second derivative there. So let's see, let's go purple this time. All right, so I'm going to take my velocity, and I'm going to take the derivative, so it's s double prime of t, which is the same as v prime of t, which is the same as a of t. The derivative of that is just going to be negative 9.8. Now, why does negative 9.8, why does that come up? Gravity. So this is accelerating at the speed of gravity.
Oh, so it's at double prime acceleration.
Acceleration, that's what they're accelerating at. Okay, and so that would be negative 9.8 meters per second per second. So for, yeah, because there's no variable here to plug in anyway. So no matter what, that's what the gravity is going to be, and that's meters per second squared. All right, so we got acceleration. How long is the ball in the air? So I want to know what. So think about it. Think about my different formulas I have. So I want the ball to be where? At 0, right? So I want time equals 0 is going to be my starting, right? And then I want to find out when my height is also going to be 0. So I need to use what function? The position, right? My position, my S. So I'm going to take my S. And set my position equal to 0. So if my position is equal to 0, I start off with, do they have a common factor? They have a t. Anything else? Is there 4.9 in both of them? There is a 4.9. So you could divide 29.4 by 4.9, right? And what do we get? 6? Negative 6. There you go. So, but we'll get it here in a second. So I'm going to take out negative 6. So negative 4.9 t, and I'm left with t minus 6. Now, by factoring it, it's going to make my life really easy. Zero product rule means anything times 0 gives me 0. So to make this true, this first one, I get t equals 0, right? So that's for this one right here. So if t is 0, anything times 0 is 0, that makes that true. My next part, what would make the second one equal to 0? 6. So you'd say t equals 6. Because that would make the second part here equal 0. So in regards to this problem right here, at t equals 0, it's starting where? On the ground. And at t equals 6 is when it comes back down. So it's in the air for 6 seconds.
You're just finding the zeros.
But there's reasons for finding the zeros now. So before, when you would do this in other algebra class and whatnot, you would have some graph, and we actually have applications for these now. That's what all your math classes up to this point have been leading to. What is the velocity of the ball upon impact to the ground? And what is its speed? So, let's see. So we're going to plug that in. We plug that in where? The first derivative, right? So I'm going to find the velocity and then the speed. And just like someone over here said, that speed is the what?
Absolute value.
Absolute value of my velocity. Because velocity can go forward or backwards. You can have a positive or negative velocity. And then, but the speed is whichever way it's going, the absolute value. So it's going to be the distance there. So Let's plug in 6 into my derivative. So v of 6 is going to be negative 9.8 times 6 plus 29.4. Huh?
Negative 29.4. So I got
Negative 29.4? Okay. And so that's my velocity in meters per second, right? But the speed is going to be the absolute value. So the speed is meters per second, 29.4 meters per second. Total distance traveled by the ball. Which function do I want to for finding the total distance? Position, right? Starting off, my s of t. So I'm going to plug in s of 6, and that's going to give me my distance traveled. S of 6, negative 4.96 squared. Zero.
Yeah.
Because that would.
Oh.
Because typically the distance
Oh, it went up.
It goes up and then comes back down.
Would that be really the total distance then? That
Total
was
distance is 0, but wouldn't like this basement is how you calculate it?
So for total distance traveled, you have to go from here up. So where do we actually get the highest point? At 3? So it should be, since it's going up, so it's a positive this direction here, right?
it'd be double back.
It would, very good. It would be double. Because what do we know about the distance after that? It's going back down, right? So it's going back down. So it's going to be my total distance.
The only reason why we get 0 too is because we are counting the distance down as negative 2. So
Yep.
It's positive.
So it's going to be 88.2. There you go. All right. I'm going to post some skills check in the AP classroom. So I'll post a couple of them in there for you. So you guys wanted more, so I'll do those. All right. Distance going up, right? And it's going to be the same distance going down. How many balls do you know that actually do make like a x cubed type of? There is others, but we're not getting to those problems.